Welcome back. I'm Mr. Goan, and we're going to be looking at the National 5 Applications Unit Outcome 1.2, specifically looking at vectors with directed line segments, vectors in component form, the magnitude of a resultant, and coordinates in 3D. What we're going to do, we'll get started with these questions just now. So, question 4. The diagrams below show two directed line segments, U and V. And we can see that U goes horizontally along 3 and then 2 up. U looks like that. And V goes 1 horizontal and 3 vertical, looking like that. And important to note that they each end in an arrowhead, denoting where the nose of the directed line segment is. Now, our question is to draw the resultant of 2U plus V starting from the bottom left corner. So drawing in this resultant, and I'm just going to draw it in starting at our bottom left corner. 1U is 3 across and 2 up. A second U would be 3 across and 2 up. And our V comes in at 1 across and 3 up, like that. And finally we can draw our resultant, which red and blue make purple. So I'll draw in my resultant like that, and see my resultant again ends in a little arrowhead. Now, it is important to note that you can draw these in any order. Oh, moved the wrong thing there, sorry. You can draw these in any order. For example, if I were to instead have drawn U, then V, then U again, it still goes to the same place. The resultant will always end up in the same place regardless of the order we do these in. Now you can get the marks for doing this in component form. For example, U is equal to 3, 2, and V is equal to 1, 3, giving us that 2U plus V would be equal to 2 times 3, 2 plus 1, 3, which is 7, 7, 7. And starting at the bottom left hand corner, 1, 2, 3, 4, 5, 6, 7, and then 7 up, 1, 2, 3, 4, 5, 6, 7. If we calculate that and draw a resultant vector, that's fine. Question 5 is a 3D coordinates question. The diagram shows a square-based model of a glass pyramid of height 8 centimeters. The square OABC has a length of side 6 centimeters. The coordinates of A are 6, 0, 0. Remembering that our coordinates are x, y, z. C lies on the y-axis. So we can see that C goes from 0 backwards into y. Now we were told that the square has a base of side length 6 centimeters and its coordinate is 6 long on x. So we can assume then that 1 unit on x is 1 centimeter. The question asks us to write down the coordinates of D. So I'm going to make this a little bit bigger so we can see it nice and clear. D is the tip of the square-based pyramid, and that happens directly above the center of the pyramid. So just thinking about the 3D shape, the center of the pyramid should be there. In order to get to that, we would need to travel halfway along x, which would be 3. We would then need to travel halfway along y to get into the center of the base there, which is another 3. And during the question, we were told that the pyramid itself was 8 tall. There's our 8, giving us the coordinate D, 3, 3, 8. Brackets are important when you're giving your coordinates, and you can see that is 3 along x, 3 into my page on y, and then 8 up z to get to D. Question 6. The forces acting on a body are represented by 3 vectors, P, Q, and R, as given below. P is 8, 1, 3.5, Q is 2.5, negative 12.5, 9.5, and R is negative 1, 5.5, 10. Find the resultant force. Well, if all 3 of these vectors are acting on a body, what we have here is a force of P plus Q plus R, which in component form gives us 8 plus 2.5 plus -1, 1 plus -12.5 plus 5.5, and 3.5 plus 9.5 plus 10, which when we sort that all out, 8 plus 2.5 is 10.5, minus 1 is 9.5. 1 minus 12.5 is -11.5, plus 5.5 would be -6, and 3.5 plus 9.5 is 13, plus 10 is 23. And there's our resultant vector. Remembering brackets are important. Without the brackets, you get no marks. And finally, question 7. The vector A, 5, -3, and the vector B, -3, 0. Calculate the magnitude of 2A plus 3B. Well, to start with, we're going to work out what 2A plus 3B is. So 2A plus 3B is going to be equal to 2 times 5, -3 plus 3 times -3, 0, which gives us then 10, -6 plus -9 plus 0, giving us that 2A plus 3B is equal to the vector 1, -6. Now the magnitude of 2A plus 3B is going to be equal to the square root of 1 squared plus -6 squared, which gives us that the magnitude of 2A plus 3B is equal to the square root of 37. And that's it. So good luck with applications 1.2, and any questions, contact me on MrGoanMaths@gmail.com. Till next time, bye.